Welcome to day 2 of making a text generating model from scratch in Python. So in my last video, I have made the predictors and levels. I've converted it into tokens, like converting the data into tokens and converting it into sequences. Now we are gonna convert levels to categorical. Okay, this will convert each word into a vector. Like example, cow, cat, dog. So this will convert them into vectors. Like for cow, let's take 1 0 0 cat 0 1 0 dog 0 0 1. Okay, like it will be in a list. Okay, like that. We're converting it into uh categorical levels sensible to curious to utils to categorical level and new classes equal to total words. Okay, let's just convert. Or we're gonna convert levels. Okay, levels into categorical. Okay, just put level. You can see it's tensorflow.keras.utils.to categorical, which is tensorflow.keras.utils dot right spelling categorical te get categorical. Okay, next this takes levels and num classes as parameters. So let's just put level. So this is the level, and then it takes, what was that? It's the num classes, num underscore classes equals its total words. Let's just try it. It's not test.py. Sorry, this is this one. Training.py. Okay. Levels, num classes, total words. Okay. Now, finally, we are making a text generating model. Here I have written a bidirectional layer. This layer. Okay. Now, it processes the input sequences in both forward and backward direction. It is like having two LSTM layers. What is LSTM? LSTM is the short form for long short-term memory. One reading the sequence from the beginning to the end and the other reading it from the end to the beginning. By doing this, the model can capture information from both past and future contents, which can be useful for understanding the meaning of sequences. Here we use this so that you know it takes input sequences, like it processes the input sequences in both forward and backward direction. Now if I don't put this, then it will just like work with one direction, the forward. So if I don't put this, so the processing can be faster. Okay, but uh you know the model will not capture the information from both sides. Running this. Okay, so levels is done. So next, finally, we are now training the model. Okay, making making the model. Okay, it's making, okay, not training. So let's just make model equals to tensorflow dot eras dot, I guess it was sequential. Okay, UUENTIL. Okay, the sequential model. So, okay, yes it is. Next we are putting embedding and total words. Okay, just copy paste it. Paste. Let's see now. So it's taking the parameters, total words. It's transfer for the keras, the layers that embedding. It's taking total words and 100. What was that? Let me just, no, I cannot open it. Let me just import Kiras. Okay, let's see now what's this. Turns positive integers indexes into dense vectors of fixed size. Okay, so this is what embedding does. Embedding there. Model TensorFlow character sequential. No, embedding. So example, it takes this, turn positive integer indexes into dense vectors. It takes 4 and 20 and converts them into this and this. Okay, so this is what embedding layer does. Let's just have a closer look at other things. It takes input dim, output dim, layer uniform, then input length, input length, input length is max sequence length. So it's the longest sequence. Okay, it's taking that. Let's just do one more tensor dot eras. Just remove this. Okay, TensorFlow dot keras dot layers. Again, once more TensorFlow dot keras dot layers dot, or was it bi bidirectional? Bidirectional. No, it's bidirectional. Yeah. So let's just TensorFlow dot keras dot layers dot lstm, long short term memory. So we are putting it 200. So 200 means how many parameters it will have, like the complexity of the model. Then we are passing it through an activation function, that is softmax. Okay, so TensorFlow dot eras dot layers dot dense. So it's taking the total words as parameters. Okay, then next it is going through an activation function. Activation. Okay, activation is softmax. Now that's done. Now we are compiling the model. Model.compile. Optimizer add a matrix accuracy. Categorical this, just copy paste. Uh, Compiling the model. Now we have done the compiling. Okay. Adam, it's an optimizer that is used for text generation mostly, as far I know. Okay, I can be incorrect. I'm not like very much familiar with these things. I'm new to machine learning. Okay. So next it's doing training the model. Okay, now we're training the model. So model.fit. Now what does the model.fit takes? It takes the predictors, converting labels to categorical. What's this? Okay, predictors. So this one. Predictors, and it takes level, then epochs, like how many time it must keep on training. Let's just put it predictors level and epoch. Let's just do 100 because it's a small model, so it won't have that much problem going forward. Next, we are training the model. Wait, I have not put this verbose, verbose, verbose. Okay, is it is one? Why? Like it will just show like the accuracy and all that on training process. Then and finally, wait, next it is model.save. Okay, it's saving the model. Let's just do model.save. Is let's put one name. Okay, let's just put it model one. Then let's just print here model has been saved. Okay, so that's all. Okay, it's taking a data set from data underscore underscore that's here. It's a small data set, and I have this other one that's really large. So I'm not gonna train this large one for now because it will take a lot of time. Let's just continue with the smaller one, this one. So now let's just run it. Now here you will see that I have used some extra things like importing numpy and all that. So here I have uh, trained the model. I have saved the model. Here I'm using the model right after training. Okay, here I have saved the model, but still I'm using it. It's wrong here. TensorFlow as the sequential method argument. Which one is the sequential? Okay, okay, it's inside this. Okay, now it must work. CLS. Okay, okay, now let's continue with this one. Here, I'm using the model. Like I made a function generate text, import numpy as np, for def generate text, seed text, that is this, like the first word, and then it will keep on generating. It's wrong again. Model dot read and the keyword epoch, epoch. So what was this value? Oh, it's epochs. Okay, now it must work here. Paired sequences, tokens, list, or suppress the bar output, blah blah blah. Uh, let's just copy paste it for now. Using the model list. Okay, here it's saving the model. Let's remove it for now. Okay, so you can see its accuracy 0.845. Its loss is this. Okay, here you can see the model is saved. Model saved. Now, what if I try running it for 150 bucks? Run it for C slash. Okay, it's training it 15, 18, 24, 26, 30, 40, 48, 60, 70, 80, 90. Okay, so its accuracy is going up to 95, 0.95. It's 95%. Okay, model has been saved. We can't print this if you have not saved the model. Now, let's test it. Hello, hello, how may I help you? It's working. Uh, are you Lina? Yes, I am Lina, a text generating model made for helping human. Let me just check. Yes, I am Lina. Okay. Uh, what yo? What can I do for you? Yo, what can I do for you? Um, okay, it's not that great, but yeah, its responses are not wrong also because it's a small data set. Are you accurate? 20? Yes, I'm okay. It's not algorithms. Yes, algorithms. Okay, here you can see it's breaking here. Now let's just put on hello and let's try for 50 words. I help you humans algorithms. Yes, I am Lina. What Lina? What Lina? What Lina? What Lina? Humans algorithms. Hello, how may I help you? Think. Now let's just put 30 words here. Hey, how can I assist you today? I'm designed in help your task. Yes, yes, algorithms, yes, assist you accuracy, takes after problems pro. And so it's working fine enough. I know it's not that great, but yeah, it's working. Uh, Here I am using the model import by SNP. Def generate text. It's taking three parameters: seed text, next word, max sequence length. Then we are printing the seed for underscore in range next words. Okay, for like 50 words, it will go on for 50 words. And text list, tokenizer to text to sequence. Then seed text 0, token list, pad sequence, padding 3, max length, sequence length minus 1, output word, prediction numpy dot array dot model dot predict, suppress the population bar output, then tokenizer the word index dot items. Okay. If index equals to predicted output word equal to word, see text this plus equals this printing finally using the model. Yeah, so that's it. That's our text generating model. Thanks for watching.